since it's minus 65 microcoulomb here, we said charge is conserved. So the other will be positive 65 microcoulomb, so that when you find the net for electric field, electric charge, it will be 0. We already did all these ones in class, so I will not waste time calculating all these ones. We've also solved a question like this. Calculate the electrical resistance of a copper cylinder wire that is 0.5 meter long and has a radius of this. This is the resistivity E. Now say calculate the resistance. Resistance is resistivity times L divided by A. So our resistivity is 1.7 times 10 raised to the power of minus 8. Our length is 0.5 meter long. Now the area will be the area of a cycle, which is pi r square. So this is 3.142 times radius, convert it to, which is 0.045 square. So our R will be equals to, now punch all this in your calculator. You are going to get your answer. 1.7 times 10 to the power of minus 8 times 0.5, okay, divided by 3.142 times 0.045 square, give us 1.34 times 10 raised to the power of minus 6. So that is our resistance, 1.34 times 10 raised to the power of minus 6 ohm. A very simple question. Alright, so that will be that. Now let's see the next one briefly. Now the next will say a piece of styrofoam has a charge of 0. This and is placed 3 meters from a piece of salt with a charge of this. How much electrostatic force is produced? All these ones are very simple question. K Q1 Q2 all over R square is the electrostatic force. So F will be K is 9.0 times 10 raised to the power of 9. The first charge is 0.04. The second charge is 0.003. The distance of separation is 3 meters, which is 3 square. 3 square will give us 9. 9 will cancel 9 from here. So F will be equals to 3 times 4 will give us 12. Right? So we already see the answer there. 3 times 4 will give us 12 times, this is 10 raised to the power of 9 times 10. Now how many zeros are here? 1, 2, 3. Are you getting it? 3030. Add them together, minus 6. Which of course will give us F is equals to 12 times 10 raised to the power of 3. Which of course we're supposed to give us 12,000 Newton approximately. Alright? Oh, let me just press it. 0.004 times 0.003. That is 1, 2, 3, 4, 5, 6. Okay, we're actually correct. So that will be that for that question. It's supposed to be one more 0 here. Which option? D. Alright? So let us see the next question briefly. The next one. Now, which of the following is true about Gauss' law? It states that the surface integral of the normal component of an electric field, it states all that. The correct answer is all of the above. Option A. Are you getting it? You can read through everything you have here, but we don't have that time currently. So correct answer is all of the above. Now, next question. An electric oven has a rating of 2000 watt, 240 volt. Calculate the resistance. P is equals to what? IV. The same way, P is equals to what? I. V is what? IR. So P is I square R2. What we are looking for is R. But we are giving, okay? There's actually one other formula we can use. P is also equals to V square over R. What we are looking for is R. So PR will be what? V square. I've given you all these formulas. That is the reason why I'm not solving too much. R will be what? V square over P. What is our voltage? 240 volts. So this is 240 square divided by 2000 watts. So we have 240 square divided by 2000 watts, which gave us R as 28.8 ohm. Option A. Is that okay? 28.8 ohm. Now, the field intensity of a point close to a charged plane conductor situated in air is this. The surface charge density is. Now, how do we calculate for the surface charge density? Now, there's a formula for calculating for the surface charge density. I'll come back to this particular question. Three capacitors whose capacitance are 1, 2, and 3 microfarad are connected in series. Find the equivalent capacitance of the combination. They are connected in series. Now, we say if they are connected in series for capacitors, what do? You find the reciprocal of each of them. So 1 over 2 plus 1, okay, supposed to be 1 over 1 first, plus 1 over 2 plus 1 over 3. So 1 over C equivalent will be, the LCM of this is 6. Here will give us 6 plus 3 plus 2. So 1 over C equivalent will be 6 plus 3 plus 2, 9, 11 over 6. So to find C equivalent, we say we invert. C equivalent will come up, this one will come down. This one will come up, this one will come down, which will give us 6 over 11. So C equivalent will be 6 over 11. Now press your calculator. 6 divided by 11, 0.54. Are you getting it? 0.54. We can take 545 microfarad. Option B is the correct answer to that question. Let us see the next one. A 6 microcoulomb charge is placed at the origin, and a second charge is placed on the s-axis at s equals to 3 meters. If the resulting force on the second charge is this, what is the value of each charge? So it's the same thing. F is K Q1 Q2 all over R square. Now, the resulting force is 5.4 coulomb. K is 9.0 times 10 raised to the power of 9. Q1, the first one is 6 microcoulomb, which is 6 times 10 raised to the power of minus 6. Q2 is what you are looking for. The distance of separation between them is 0.3 square. Is that okay? Now, there's something I want you guys to do. You can put this in your calculator, you get the answer. But 0.3 square will give us 9.0 times 10 raised to the power of minus 2. I want to use my brain to solve without calculator. That's what I want to show to you guys. So 0.3 square will give us this answer here. So this one can cancel out this. Is that okay? Exactly. So what you'll be left with, this 10 raised to the power of minus 9, 10 raised to the power of 9 minus this. So here will be 5.4 will be equals to this, and this will give us 6 times 10 raised to the power of 3. Are you getting it? Times what? Q2 divided by 10 raised to the power of minus 2, which is this one under. You can press all this in your calculator and find your this, I'm just trying to use my brain and get the answer quickly. When this one comes up, it becomes 5.4 times 10 raised to the power of times 10 raised to the power of, when this one comes up, become 3 plus 2, which is what? 5. Is that okay? No. 5.4 will be equals to 6. When this one comes up, it becomes times 10 raised to the power of what? 5. Q2. Divide both sides by 6 times 10 raised to the power of 5. 6 times 10 raised to the power of 5. Are you sure this thing is correct like this? Our Q2 will be 5.4 divided by 6. Okay, is correct. Which will give us 0.9. When this one crosses up, it becomes times 10 raised to the power minus 5. So your Q2 would be equals to 9 times 10 raised to the power minus 6 coulomb. Minus 6 coulomb is microcoulomb, so Q2 will be 9 microcoulomb, which is option D as the correct answer to that question. Is that okay? Let us see the next one. Now the next one says determine the current density if 50 ampere of current flows through a battery with an area of this. Told you that current density J is I over A. So this one is a very straightforward question. I is 15 ampere. The area is what? 10. When this cancel this, the correct answer is 5 what? Ampere per meter square. Option A. Is that okay? Take note of that. The current density is I over A. Now, the force of repulsion between 2-point charges, 5 microcoulomb and 8 microcoulomb at a distance. This one, not something we should be wasting time on again. Q1, Q2, all over what? R square. So F is 9.0 times 10 raised to the power of 9 times Q1. Q1 is 5 times 10 raised to the power minus 6 times Q2 is 8 times 10 raised to the power of minus 6 divided by R 0.2 square, because this is 2 centimeters, it's supposed to be 0.02 square. So punch this in your calculator and you get your answer direct. So 9 times 10 to power of 9 times 5 times 10 to power of minus 6 times 8 times 10 to power of minus 6 divided by 0.02 square, which will be 900. So our force is 900 Newton. Option B. Is that okay? Option B. Now, the next question here says, will a 10 ampere fuse blow for a steady rate of charge flow through it of 45,000 coulomb per hour? What is the charge flow rate in ampere? Now they gave you 10 ampere fuse. Now they are giving you 45,000 coulomb per hour. Now, if it is 45,000 coulomb per hour, normally Q is equals to what? IT. Is that okay? Now, what we are trying to look for is the current. Are you getting it? Now, they gave you 45,000 coulomb per hour. So, our Q is 45,000. An hour time is 60 minutes. Because per hour, 1 hour is 60 minutes. Convert to seconds will now be 60 times what? 60. Which should be what? 3,600 seconds. So let us calculate the Q is IT. Let us calculate I. I is what? Q over T. Which should be 45,000 divided by T is what? 3,600. So when we calculate that, that will give us 45,000 divided by 3,600, which should be 12.5 volts. 12.5 ampere. So it means the charge flowing in, the current flowing in through at this 45,000 coulomb per hour is 12.5 ampere, and the fuse is 10 ampere, so it will blow. Are you getting it? So the correct answer is the fuse will blow because the fuse is 10 ampere and you are passing a current of 12.5 ampere through it. The fuse will blow and the charge flowing through it in ampere is 12.5 ampere. Is that okay? That is the correct answer to that question. Let us look at the next. A drive cell of EMF 1.5 volt, and internal resistance of this is connected to a flash bulb whose resistance, what is on our story? V is what? IR. I is what? V over R. The voltage for this question was given as was 1.5 volt. Now the resistance, you have two resistance, so you add them together. One of the resistance is 0.05, the other one is 0.4. So it becomes 0.05 plus 0.4. Total resistance will be 0.45. Are you getting it now? So our I will be V 1.5 divided by 0.45. So I will be equals to 1.5 divided by 0.45, which gave 3.3 ampere. So the current flowing through is 3.33 ampere. Continuation like that. Option C is the correct answer. It's a very simple one, right? Exactly. Let us look at the next one. Now, they say a static car battery is rated at 700 Ah at 3.5 ampere, which means that the battery can deliver 3.5 ampere for approximately, which is 700 divided by 3.5, which is 200 hours. However, the larger the current, the less the charge that can be drawn. How long can the battery deliver 2 ampere? If it is rated 700 at 3.5 ampere, which gives 200 hours. Now, if it's delivering 2 ampere, it means delivering less than it's actually rated for. So it means it will last longer, which will just be 700 divided by 2, which should be what? 350 hours. This one does not require you to solve much. Are you getting it? Option C. Now, if you charge a metal board on an insulating stand by induction using a charged glass rod on plastic rod, what happened to the charge on the rod? Now, if you charge a metal ball on an insulating stand by induction using a charged glass on plastic rod, what happens to the charge on the rod? It stays the same. The answer depends on whether the charge is positive or negative. It increases or it decreases. Now, for this particular question, the charge will definitely remain the same because it is not like being transferred. Are you getting it now? So it will remain the same. Now, the next question here says, calculate the magnitude of the electric field intensity between two plates 1.5 centimeter apart. If the potential difference between the plate is this, V is equals to ED, right? V is what? 4.2 volts. The electric field is what you are looking for. The distance is 1.5 centimeter, which will be, if you divide this 1.5 by 100, will be 0.015. Abi 12. So our E will be 4.2 divided by 0.015. Do that in your calculator. 4.2 divided by 0.015. 280 volts per meter. Depends on, one of them might actually be wrong. Either the option or maybe this one is 15 centimeter. But at the end of the day, I know you will get something 280 or 2.2820, depending on how the equation later comes. Is that okay? Still have a lot of questions here. I've actually solved all these questions in your notes. 3 resistors, 2 ohm, 6 ohm are connected in series, and a 120 volt battery connected across the combination. Calculate the equivalent resistance. Now, my dear student, we say the equivalent resistance is addition of everything here, which should be 2 plus 6 plus 9. 2 plus 6 is 8 plus 9 is how many? 17 ohm. And the current is V is equals to what? IR. V is 120. I is unknown. R is 17. So I will be what? 120 over 17, which gives us 7.05, approximately 7.06. So the correct answer is 17 ohm, 7.06 ampere. All right. Now, a current of 0.2 ampere passes through a 1.4 kilo ohm resistor. What is the potential difference? V is what? IR. V is current is 0.2 ampere. 1.4 kilo ohm means 1.4 times 10 raised to the power of 3 ohm. So when you do this in your calculator, it's going to give you an answer. 0.2 times 1.4 times 10 to power of 3, which should be 280 volts. Is that okay? So that is the answer to that question. Now, the next one. All these ones, they are things that you will have calculated before. So write out the question and try and get the answer. Then this one, we've solved it in class. All these ones, we've solved them in class. So that will be that for this one. Thank you very much for your time. See you in the next one. Bye-bye.